the screen and okay, I forgot it, and I started the recording also just now. Prior to that,
Oh, okay.
I forgot this recording also. So basically, what I was saying is,
Okay.
okay, so there's something called writable and there's something called writable comparable, as similar to serializable, and all your keys are writable comparable. The data types which are there in the Hadoop are all these are the different data types which are available for you in MapReduce. All of them are self-explanatory, other than your writable, which is you can create your custom writables. Any data, if you want to make it writable, you have to implement the interface called writable. For keys, you have to implement an interface called writable comparable, and you can create your own data types also. Other than that, all are self-explanatory. So you are aware of compare to method, right?
Yes.
Okay. So input split, I have already explained to you. This is a logical division of the data rather than the physical division. So let's look at this part, and then that will make it more explanatory. So on your data, there's a split. So a record reader is a process which keeps on reading each record from an input split. And for each record, your map function is called, and that is where your mapper is really invoked. So this thing happens at the backend with the help of file input format classes. For each block, or practically basically input split, there's a record reader which is initiated from an input format. Record reader reads your record by record, each record from an input split. That is in our word count program, that will read a single line from input split, call a mapper and map function for that line, then again read the next line from input split, call your mapper function for that line, and so on. So let me show the input format first.
Miraj, can I ask you a small question? Step back.
Yeah.
So writable comparable. How writable? Understand, like you said it was more like serializable in Java, right?
Yeah, it's exactly serializable in Java. What is called, it's basically, it's called writable in Hadoop word.
Okay. So if we say that basically a float is writable, let me take example like int writable, right? So if I want to say int, if I want to define a variable which is int in Java, do I have to always say int writable? Because in Java we don't always say that it is serializable, right? Only when we want to.
So that's what I think. The data types over here are these. So if you remember the MapReduce code which I showed to you, there I use same data types. See, int writable, text, long writable. These are data types which are there, which need to be used for data, because data need to be written onto SDFS. So they have to implement serializable, and the things which are implementing serializable are basically called as writable in Hadoop.
Got it. Now there is a next. Okay, so can you go slowly here? So I get this one. What is null writable means? Means anything which is null.
Null, yeah.
Okay, so there's null and there's a empty string भी है क्या यहाँ पे? String मुझे दिख नहीं रहा.
String, text है. Text for that thing, there's something called text.
Okay, so वो text को अच्छा text को उसने पहले से ही मतलब implementation में writable डाल दिया तो उसको बोलने के लिए जरूरत नहीं है, right?
Yes.
Okay, now let's. And your writable, you are saying that you can use the interface writable, implement the interface writable, and write your own value
So,
type.
so let's say I have an object called design Pathshala, which has employees, and then inside employee salary, and inside salary there, and other than that there is structure and things like that. I'll create my own
Hmm.
class. I'll implement a writable for that thing, and then that will be writable into SDFS.
Okay. Right. Okay, got it. Now let's go to the next slide, which is you said comparable is same as compared to. So
So
is
basically,
writable
comparable
comparable?
class, writable compare has to implement it compared to kind of thing what we do in Java only. So there's something called comparable in Java, right?
Hmm.
Same thing you
So
have to
basically, in Hadoop world, this is this a class writable comparable?
interface again. You have to implement it for your keys.
Interface, correct?
Hmm.
Okay, got it. So writable interface. Okay, we'll call this
इंटरफेस है
data method.
सब इंटरफेस ही होगा क्लास तो नहीं होगी ये एब्स्ट्रैक्ट क्लास नहीं होगी इंटरफेस ही होगा इट माइट बी एब्स्ट्रैक्ट क्लास
इंटरफेस
प्रॉब्ली इट
होना
शुड बी
चाहिए.
इंटरफेस ओनली
ओके, ठीक है. So basically, okay, now we go. So basically, इसका फंक्शन ये है कि ये writable comparable जो है ये तुम्हें सीरियलाइज्ड ऑब्जेक्ट को के कीज को कंपेयर करने के लिए यूज होता है.
बेसिकली जितनी भी हम कीज टाइप हैं यहाँ पे जितनी भी मैं कीज बनाऊंगा दे शुड बी कंपेरेबल क्योंकि they has to be compared on the short and shuffle phase. So they have to not only to be writable, they have to be comparable also. So like long can be compared to each other. So that's the reason I was able to make long as a key. Text I can compare to each other. That's the reason I was able to make it. But when I'll create my own, when I create my when I create my own writable, if I want to use that data type as a key, then I have to implement the comparable also, and I have to implement that compare to method also, so that those can be compared up at the short and shuffle phase. Otherwise, short and shuffle phase will not be able to compare my data.
राइट, ओके, गॉट इट. और ये टेस्ट का डिफॉल्ट 2 GB होता है क्या?
So this is the size which you can give for text.
Okay, let's go to the next one. So input file size, input split size.
So input split we discussed about. The input split is that is the logical division of the data. So this is what I was explaining to you. So input split is the logical division of the data, and for each input split, so input format is a class which basically reads your input split. So that will initiate a record reader for you. Record reader will read a record from input split, and for each record, a map function will be called up. So in our word count program, for each line, this map function will be called up. That is called with the help of this record reader.
Okay, so let me just correlate this with what we had. So the input file is the block, correct? One block.
No, this input file is the whole file.
Complete file.
Yeah,
Okay.
So this is your data folder. This is your data folder. So I said map reduce इस data folder पे चलना है तो यहाँ पे suppose दो files पड़ी हुई हैं तो एक ये file है एक ये file है. This is your first file, this is your second file on which your map reduce basically running up this on this whole folder. So this file has 3 blocks, 1, 2 and 3, and this file has only one block.
तो ये जो okay, तो जो पहला वाला बड़ा वाला है उसका इनपुट 3 ब्लॉक के अलग अलग चल रहे हैं.
हाँ तो हर ब्लॉक पे ऑलमोस्ट एक इनपुट स्प्लिट बनेगी लॉजिकल डिवीजन ऑफ द डेटा on that input. So for each split I told you one mapper. So for each split there is one mapper. Right, and there is a map function in the mapper. There is a map function in the mapper. So this map function is invoked somehow. So who invokes this map function is this record reader, basically input input file format, so which has a record reader implemented in it. So that record reader reads a record from input split. That is one line from the input split, call a map function, read another line, call map function, read third line, call map function, and so on.
Okay.
Okay, so if you remember, we don't implemented any input format, we don't implemented any record reader, we didn't did anything, but our program ran up. So how it ran up basically? We have so this is what I explained to you right now. We have a lot of already implemented input formats for us. The default one, if you don't define which input format we want to use, is the default one is text input format, which treats /n as a terminator for a line for each record. That's the reason we were getting data record line by line. Its key is long writable, its value is text. So if you remember, we were getting keys as a byte offset and we discarded those, and we were getting the value as a text, and we basically splitted the word split the text by space, and we created each word as a key from the map phase. Pravjit, you are with us?
Yes.
So that all thing was done with the help of text input format, which is a default file input format. If you don't define anything, this is the default one which is invoked, and this is what helps us to read the file line by line. So if you remember, here we give key as long writable and value as of type text, because the default one was invoked up and that returned up this kind of data. Then there are other file input formats which are already implemented for us. There's something called key value text input format. What it does is you just define a character on which you want to split your data, and based on that character, it will divide your data into key and value. So if you set tab is a separator, so anything prior to tab will become your key, and anything after your tab will become your value. So your map function will be called with this thing as a key and this thing as a value. And in this case, key will be text only, value will be text only, because it's reading the data from your file. Similarly, there are others also, sequence file input format. So sequence file will cover up in our file format classes. But for a time being, remember there's a reader for sequence file input for file format also, which reads your sequence files. So there are a lot of different file formats and compressions, which you have to understand thoroughly to really run your programs at a good speed and to optimize your things in the Hadoop cluster. So once you understand the file formats and the compression techniques in the Hadoop cluster, you will be able to basically, fine tune your programs, fine tune your things which are running very slow in your cluster. And also you will be able to figure out what is the optimal file format for different data, which compression I should use up so that your data is properly sorted out and everything is running code in our cluster. So I'll walk you through the different file formats which people use up and which are suitable for different things and compressions. So this will cover what is the sequence file format, but for time being, just I wanted remember there's an input format for sequence files also. So you don't have to define any of your reader for sequence files kind of thing. Similarly, there's something called n line input format, which is guaranteed that your each split contains only have n lines.
Miraj, can I ask you a small question?
Yeah, go ahead.
For the sequence file input format, can you give an example like how if we have dealt it so far? मुझे उससे थोड़ा अच्छे से समझ में आ जाता है.
Sorry, how?
So in sequence file input format, okay, input format for reading in sequence files. So key and values are user defined and their specific compression binary file format. So basically, I wanted to understand this with an example.
हाँ वही मैं कह रहा हूँ, ये different type की files होती हैं. सो मैं जब ये सीक्वेंस फाइल दिखाऊंगा आपको तभी समझ में आ जाएगा।
ओके,
अभी सीक्वेंस फाइल मैंने
ठीक है।
बताई नहीं, उसमें डेटा जो है ना, मतलब डेटा की स्टोरेज की फॉर्मेट ही अलग होती है। यू स्टोर योर की एंड देन योर वैल्यू इन योर सीक्वेंस फाइल एंड देयर आर पॉइंटर्स, स्पेशल पॉइंटर्स, so the file format is totally different. So that's the reason you just remember there's something called input file format for sequence file also, so that when you're dealing with a sequence file you can just directly use it. But when you look at the real sequence file, how the data is stored in that, then you will understand कि वो user defined क्यों है. So I'll explain you that thing in the file input format. Right now, if I go to that thing, that will again take 15-20 minutes. Sequence file, because I have
Okay,
to
no,
explain you whole file format.
okay, no problem. Okay,
So,
thanks.
so there's a record reader which is associated to each input format, and for text input format there's a text record reader. For key value text input format there's a key value record reader, and similarly. Where's the record reader? Here it is. So record reader reads your data. Sorry, text input format is a line record reader rather than text record reader. So there's a line record reader which is there for text input format. So each of these input formats basically implement their own record readers which read the record by record data from your HDFS. So the name of that is not text record reader. That the name of record reader which is used by text input format is line record reader. And what I'm saying in this slide is you can create your custom input formats. Definitely, as I told you, everything is configurable over here. You can create your own custom file input formats. Again, you have to implement the corresponding classes and you can create it. All those examples are there in the code which I've shared with you. Custom input formats, implemented, writable, uh, comparable, जितने भी मैंने चीजें अभी तक बताई हैं सबके यहाँ पे एग्जांपल्स हैं. I'll walk you through them. There's a there's a file input format which has been created over here. Shut the input format. Uh, File format key value. Which is the file format? So there's a custom writable which is implemented over here. So if you see, I have implemented writable comparable, and this long writable is used as a key in the mapper. So there is a custom input format. So this is implementing file input format, and it would be it's created its own record reader. So record reader is created for us, which is extending the record reader, and we implemented the logic of record reader and created our own input format, file input format. So all these code samples are here. I'll walk you through them. As much as deep you want to go, I can go over here. So we'll walk you through these different code formats which are there. So whatever I'm talking over here, all the sample codes are there in this repository which I've shared with you. To search the corresponding thing, just follow the package names that will guide you through इस package के अंदर किस type का code होगा basically. So what I was saying is there's a record reader for each input format. For text input format, there's something called line record reader, and similarly for others, I don't remember the exact names for the record readers which are there for the corresponding thing. So key value text input format has a key value record reader, and you can always create your own record reader as I shown over here. Here we created our own record reader by extending the record reader. Is it going too complex or is it going fast or it's okay?
I think I am fine.
Okay.
Little fast actually.
Fast
I'm
to you.
just
And
trying to
any
relate.
questions? Are you able to get it? Or any questions or getting nothing?
No, no, I'm a little bit confused, but I think that will be cleared when I see the actual code about this record reader and the input formats, and this split which you have, discussed the last slide and file and all those things. So I think
So
it will be more
bas-
clear when we see the examples.
so let's say this is your file. There's a file which has, so let's say this is my data which I want to process. That data has two files. मैं क्या दबा दिया? File 1, file 2. So this is the data which I'm processing with my MapReduce program. That is two files, and this is your block 1 for the file. This is your block 2 for the file. This is your block 3 for the file. This is your block 4 for the file. This is your block 5 for the file. So and this is a split 1 for the file. This is a split 2 for the file. Split 3 for the file. Split 4 for the file, and split 5 for the file. So there is a one mapper associated to each split. So this is a mapper 1, there's a mapper 2, there's a mapper 3, there's a mapper 4, there's a mapper 5. Let's say this file, this is split as a data. I am in, okay, let's say some random data. I'll not. And let's say I am not defined any input format for it. So in that case, there's a default input format which will invoke is a text input format that will read your data line by line. So your map function first will be called for this first line. Second time your mapper function will be called for this line. Third time your mapper function will be called for this line. Fourth time your mapper function will be called for this line. For this map, for this instance of M1. Similarly, for other instances of MapReduce, the data for on this data, the map function will be called up. So who will do this all this thing? Who will call your mapper function? Who will read this data for you? Who will create the keys and values out of data? This thing is done with the help of your input formats, input file formats. So input file format consists of one thing, what is called your record reader. Record reader basically reads your data record by record. So this record reader will read the data first line from your data. Will call your mapper map function. This mapper map function will call for this. So this is done with the help of record reader. So this is what we were looking at, and there are other implementation record readers like key value text input format. So let's say you want to read your data something like this. This is, let's say, slash e tab, or let's say comma separate.
One thing, just one thing. In this example, so what will be the key and value?
The text input format key is byte offset of your line. So byte offset is nothing but the number of bytes which are there prior to this. So if you're using text input format, the key would be 1, and then your value would be this thing, because number of bytes before this is 1 or 0 practically. Then let's say these are 24 bytes, so your key would be 25 now, and your value would be this thing, and so on. Now let's say I am using, rather than text input format, I am using key value input format, and here I've defined a separator as comma. So what will happen? My key will become dfds, and my value will become sdf. Similarly, my key will become dsf sd, and my value will become dfd, and so on.
In this example, we are taking new line as well as comma, right? Both
This
we are taking.
example, so the record is separated by new line only.
Okay.
The keys and values are separated with the help of this property, which is defined in the key value input format, which we have defined rather than slash t. Let's say we are calling it comma. So if we are
Okay.
calling it
And in
comma,
this example, if we have same key in that case,
वो तो हर बार कॉल होगा ना, मैपर का मैप फंक्शन हर बार कॉल होगा. उस मैप फंक्शन के लिए मैप फंक्शन टेक्स ऑफ
सेम,
3 थिंग.
फर्स्ट लाइन सेम है तो, फर्स्ट लाइन सेम है तो वो की तो रिपीटेड होगी ना, जैसे डी एफ डी एस कॉमा एस डी एफ, फर्स्ट टू लाइन में सेम चीज है,
Let's say something like this.
1 2 कॉमा दोबारा से 1 2, हाँ इसमें क्या होगा?
कुछ नहीं होगा, इसका मैप फंक्शन आपका इतनी बार कॉल होगा. मैप फंक्शन यहाँ पे आपका 1 2 3 4 बार कॉल होगा. फर्स्ट टाइम की होगी 1, वैल्यू होगी 2. सेकंड टाइम की होगी 2, वैल्यू होगी 3. थर्ड टाइम वैल्यू की होगी 1, वैल्यू होगी 2. फोर्थ टाइम की होगी 2, वैल्यू होगी 3. अब मैप फंक्शन उसका क्या कर रहा है, दैट डिपेंड्स ऑन मैपिंग लॉजिक. मैप फंक्शन में आपने क्या लॉजिक लिखा है. दिस इज अ मैप
गुड योर
फंक्शन.
पॉइंट, या
दिस इज अ मैप फंक्शन विच हैव रिटन. अब उसके हम की और वैल्यू का क्या कर रहे हैं, दैट इज व्हाट यू आर डूइंग विद इन द मैप फंक्शन.
राइट राइट राइट, हम वो कीज को कंबाइन भी कर सकते हैं,
वो
या
इससे
जो
और
भी हम
विश,
कर
व्हाट
रहे
यू आर
हैं,
डूइंग,
या
व्हाट यू आर डूइंग इन द मैप फंक्शन, दैट्स योर विश.
या दैट्स टोटली सेपरेट, ओके.
So reading the data, this is what I told you. We have already looked at this all things. Mapper we have looked at. So there is something called map function which has key, the value and the context. It contains keys and values are iterable comparable. So we have created our mapper class. They are already implemented some mapper class for you in the Hadoop world, which you can use at some particular scenarios. So in that case, what you have to do is uh, so rather than giving over here हमारा word count reducer है, हमारा word count mapper, हमारा word count mapper class, this class which we created up, what you can do is you can just give these classes which are already implemented for you in the Hadoop world. So there's something called identity mapper. As the name suggests, it does nothing. It just passes a key as a key only and value the value as an output. So इसके अंदर कुछ नहीं हो रहा होगा. Internally ये कुछ नहीं कर रहा. जो इसकी की आ रही है उसको context dot write में की कर रहा है और word को value कर रहा है. It does not do anything. So it just map your keys to the key and value to the value. Inverse mapper, inverse it, value की बन जाती है, key value बन जाती है. regex basically generates a match and the count of the corresponding regex expression which you have given to it. Token counter counts or tokens. So these are already implemented mappers for you which you can use it. Otherwise you can write your own, definitely always. So as I told you, reducer gets your key and values become iterable in the short and shuffle phase. Keys are writable, comparable. Similar to your input file format, there is something called output file format. So if you remember in our code, we have just defined the reducer and the mapper, nothing else. So there is a default output file format which invoked for us. So similar to your input format, there is a record writer which is associated to your each reducer. So there is an instance of output format which is associated to your reducer, and the output format implements its own record writer. This record writer really writes your data to an output file into your HDFS. So the default okay, so before coming to that output format, there are already implemented reducers for you. Identity reducer is nothing that writes your key as a key and value as a value. Long sum reducer is a reducer which really sums your values for each key. So in the word count reducer, we could have used this reducer also. And as I was saying you, text input format, text output format is the default output format which is invoked if you don't define your output format. So this is what it does it, and it writes your keys and values separated by /t. So if you remember, the output of our MapReduce program came as step separated only. So in Hadoop, at most of the cases, the keys and values are by default separated by slash t only, and records are separated by slash n only, and most of the places by default. Then there's sequence file output format, which can create a sequence file for you. Null output format, I don't know what it is for, but it basically nullify your output. It will suppress your output. So मुझे आज तक समझ में नहीं आया इसका use क्या है. Okay. Did you got it? You want me to repeat it or any questions before I explain you the short and simple phase? So basically similar to
You
your
can
input format, there are basically output formats and similar to their record reader, there is a record writer, and there are default implementation of mapper and reducer which you can use it rather than implementing your own. So if you are using the default ones, you can just define them over here in your job.set mapper class or job.set reducer class. Yeah, Prabhjit, you were saying something.
no, I was saying you can proceed.
Okay. Someone asked me an interesting question. I just clicked it. So one of my student asked me one interesting question that यहाँ पे mapper बाद में set हो रखा है, reducer पहले set हो रखा है. So reducer पहले call हो जाएगा क्या? So this is a configuration file only, which is just doing the configuration for you. The
ये तो
order
जॉब
of the
में तेरा
things.
सेटिंग है,
Yes. So order of the
doesn't
things does not
matter.
matter.
System dot exit.
So it waits for the completion and after that it exits.
Miraj, I think I didn't hear that clearly. So say that again. What was the question?
Hmm. Well, the question was one of my student asked it. The reducer is given prior to the mapper, so the reducer will be called first and then the mapper phase. So what I'm saying is only the configuration class. So it does not matter what is the order which you give in the things till the time it's compilable.
Okay.
Okay, so let's look at sort and shuffle phase. Mhm. Okay, so now you understand. We read the input data, each split. Map function is called for on each record of the split. On the now what happens up how the data really reaches a reducer and how the reducer gets its key and the iterable values. So basically what happens internally is as so map function is called on for each split. So there's some amount of data which can be stored up in memory. जो mapper जो output दे जा रहा है वो we can store something in the memory, but after a limit that data is spilled onto the disk. That is a local disk, not onto your SDFS. And so basically what happens up is all of these things are configurable. How much this buffer you want up, how much memory in this buffer you want up, how much so if this buffer is filled 80% you want to spill up, or if this buffer is filled 50% you want to spill up. All these things are configurable. So all of them are configurable in the config files. So basically the mapper output is stored in the buffer. As soon as the buffer reaches 80% of the memory, so 80% is the default one which I'm talking about, which is default configured. So as soon as this buffer reaches 80% of this memory, this buffer is spilled onto the local disk. There is a local node disk on where this mapper instance is running up, mapper JVM is running up. Before this data is spilled, the data is partitioned, sorted, and then spilled on the disk. Partitioned based on the partition or the basically the reducers, which so if there are three reducers intended for this whole MapReduce cycle, so this data will be partitioned into three different blocks, and each block will be sorted in it. So this is how the data is spilled onto the local disk till the time all of your split is being read and mapper is called for all the records in the split. And at the end, all these partitions are merged together on the local disk, while merging again ensure that each partition is sorted. Because these partitions were sorted, merging of them is pretty easier. You can just use a merge join kind of thing. And then each partition is intended for or one reducer. So the first So the first partition from each maple will reach your first reducer, second partition from each maple reaches your second reducer, and so on. And similarly from the other mappers, the data on the reducer comes up. As this data from each mapper is sorted, the merging of this data is pretty easy. So on the reducer, these are
Miraj, can you repeat again? Somehow your voice got missed. Like there was no voice.
okay, sure. So till where you heard?
Uh, Maybe you can just like after the buffer in memory. Like I
Okay,
didn't get anything. Yeah.
okay. 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 So your mapper of so each record on each record in the input split, the mapper map function is called up. So mapper map function ka output is stored into the local memory of the node where your mapper is running up. This mapper memory is again configured in your disk, and 80% is the spill configuration which is defined for this buffer. So as soon as this buffer reaches 80%, the data is spilled onto the disk. Again, this 80% is configurable. So when the data is spilled onto a disk, data is sorted and partitioned based on the reducers. So if there are three reducers which are intended for this whole job, the data will be partitioned into three, as you can see on this picture, and each partition is sorted in itself. And similarly, as soon as this buffer reaches 80%, the spills happen on the disk. So there are three spills you can see happen on this disk. At the end, when the whole mapper or the whole input split is being read up, all the records from the input split read up, all these all these spills which are dumped are merged together. As these each partitions were sorted, merging is pretty easy. So each partitions are merged together, and now each partition is intended for one reducer because these partitions are based on the reducer which will be consuming them. So from each mapper, the data reaches the corresponding reducer. And similarly from the other mappers also the data will reach this reducer. There is only one reducer which I'm displaying over here, and only the one mapper which I'm displaying over here. As the data on the reducer is coming sorted from the different mappers, the merging of the data is pretty easy, and at the end when the data is merged up, the reduce function is called for each key in the final merge. Did you got it now?
Yeah, but it's little confusing. Like not confusing, but I guess complex.
Yes, architecture is complex. So do you want to re-explain it, or do you want to take a break, refresh your mind, and then again relook?
Raj, can you just explain again? Like there are some other maps also, right? Other like
Uh,
other reduces, other maps, and in picture you have explained only one map and one reducer.
Yeah, so that's happen on each and every mapper. Same thing happens. हर मैपर पे यही चीज चलेगी. हर मैपर से डेटा यहाँ पे आएगा. इस मैपर से बाकी reducer पे जाएगा.
ओके, ठीक है. मुझे जो समझ आया, लाइक मैं रिकॉल करता हूँ कि इनपुट स्प्लिट मतलब जो भी फाइल से रीड करके वी प्लेस दैट टू अ मैप. मैप एक टेम्परेरी मेमोरी
Well,
में
do
रखता है
not
विच
place
इज
into the
बफर.
map. Input split से record reader डेटा पड़ेगा. Record reader sorry input file format डेटा पड़ेगा. Input file format का डेटा really record reader पड़ेगा. Record reader हर record के लिए mapper का map function कॉल करेगा. Mapper का map function जितनी बार भी कॉल होगा, हर टाइम वो कुछ आउटपुट प्रोड्यूस करेगा. वो आउटपुट बफर मेमोरी में जाएगा. जैसे वो बफर मेमोरी
80%.
ऑलमोस्ट फुल हो जाएगी, 80% डिफॉल्ट वन, अगेन यू कैन कॉन्फ़िगर दैट, सो बाय डिफॉल्ट जैसे वो 80% फिल हो जाएगी, वो डेटा स्पिल हो जाएगा लोकल डिस्क पे. नाउ माय क्वेश्चन इज व्हाई ऑन द लोकल डिस्क, व्हाई नॉट ऑन टू एचडीएफएस?
To save the network call.
Yes, and moreover, this data is really required locally, not on the SDFS, because no one else is going to read this data. Because this data need to be merged at the later point of time and need to be sent to the reducers. So that is unnecessary effort which you have to do. That's the reason this data is only stored locally. And these partitions are later on combined together at the end of the whole cycle, and each partition is now intended for one reducer. So this is for reducer 1, let's say this is for reducer 2, and this is for reducer 3, and so on. So reducer 1 वाला हर मैपर से reducer 1 पे पहुंच जाएगा. So this is your reducer 1, and similarly from other mappers reducer 1 वाला यहाँ पे आ जाएगा. ये आपस में मर्ज होंगे because they are sorted. Merging is pretty easy. And last में जो last दो बचते हैं उनको मर्ज करे बिगाड़ी वो on the fly मर्ज हो जाता है, उनसे reducer का reduce function कॉल हो जाता है. So that's the reason this is displayed 2 at the end to save one extra cycle of the merging. एंड रिड्यूसर के रिड्यूस पे आपका रिकॉर्ड राइटर कॉल होगा. रिकॉर्ड राइटर ईच रिकॉर्ड को आउट एचडीएफएस में राइट करता रहेगा.
Okay.
ये लास्ट का जो तुमने बताया ना कि दो
बेसिकली
लास्ट
क्या,
वाला जो
बेसिकली मर्ज ज्वाइन यहाँ पे हो रहा है, मर्ज ज्वाइन और मर्ज ज्वाइन, और यहाँ पे सपोज 100 फाइल्स आई, 100 पे दो दो के कॉम्बिनेशन बनेंगे, मर्ज होंगे, 50 हो जाएंगे, 50 पे दो दो के कॉम्बिनेशन बनेंगे, 25 हो जाएंगे. लास्ट में जब दो बच जाएंगे उनको मर्ज करके फिर डंप करने के बजाय वो ऑन द फ्लाई मर्ज होते हैं और उसी पे रिड्यूस का रिड्यूस फंक्शन कॉल हो जाता है टू सेव वन साइकिल. दैट्स ऑल व्हिच हैपेंस.
ओके. अच्छा, एक एग्जांपल लेते हैं जस्ट टू अंडरस्टैंड इट. सो आपने जैसे दिखाया है R1 से 1 2 3 है सपोज, ठीक है, कीज, और मेरे उसमें एक और मैप टास्क में R1 जो है वो 2 3 5 है. तो गो बैक
स्लाइड पे जाऊं.
सो या सो छोटा सा एग्जांपल है तो वहीं पे हो जाएगा. So what I'm saying is, suppose in R1 on my map task, in R1 my sequence is 1 2 3, okay, क्योंकि ये sorted है, ठीक है, और मैं सिर्फ कीज की बात कर रहा हूँ. और दूसरा मैप टास्क में सपोज करो कि तुम्हारा जो कीज है वो 2 3 4 है, ठीक है. तो उसको जब वो सॉर्ट करेगा तो does it just gets the in the sort phase, does it get block R1 which you showed on the dotted red arrow in that block, and then it gets another one from that block from the hard disk to the sort phase block, and then it does the computation there? Right?
Not able to get your question.
I'll say that again. See, the one which you have showed in the map task, which you have handwritten R1, that is the block, correct?
Yes, this one.
Right?
Yeah,
तो
this one, right?
उसके लिए हमारा जो R1 का टास्क है, सपोज करो वहां पे डेटा हमारा 1 2 3 है, कीज है,
ओके,
ठीक है. तो वो 1 2 3 जो है वो तुम्हारे ब्लॉक 1 में जो रेड एरो जा रहा है उस ब्लॉक 1 पे इट विल राइट.
यस,
ठीक है जी.
ठीक है.
उसके बाद सपोज करो कि तुम्हारा एक और हमने दिखाया नहीं है बट अदर मैप से आ रहा है.
यस.
तो उस ब्लॉक में पहले 2 3 4 लिख जाएगा.
यस.
नीचे वाले ब्लॉक में, उसके जस्ट नीचे जो ब्लॉक है उसमें.
यस.
And then yes, right. And then in this block which you are writing, यहाँ पे basically sort होगा फिर से 1, so it will say 1 2 2 3 3 4 that way, right?
नहीं, it will be 1 2 3 and 4, एंड 2 की जो वैल्यूज होंगी उनका उसका एक एरे होगा दैट विल कंटेन 2 वैल्यूज एंड 3 की जो वैल्यूज होंगी वो उसका भी एक एरे होगा दैट विल कंटेन 2 वैल्यूज.
Okay,
Keys 1
that
2
is
3
what I
4.
wanted to. 1, 2, 3, 1, 2, 3, 2, 3, 4. So can you just sample write me that value? So it will be. मैं नोट कर रहा हूँ, ठीक है. Just so it will be 1, 2, 3, 4 and 2 की एक एरे बनेगी और
सभी का एरे
फिर
होगा बट 1 के एरे के अंदर वन के एरे की साइज 1 होगी, 2 के एरे की साइज 2 होगी, 3 के एरे की साइज 2 होगी, 4 के एरे की साइज 1 होगी.
ओके.
रिड्यूसर के साथ एरे जाता ना, इफ यू रिमेंबर आई टोल्ड यू दैट डे आल्सो.
ओके. I
Reducer
got it now.
key and iterable values.
Okay, key and iterable values.
So that's how the iterable values become. वो iterable यहाँ पे बनती है.
ठीक है. ओके, ठीक है. I got it now. और ये वाला जो रिड्यूसर है वो ऑन द फ्लाई होगा, वो फिर से डिस्प्ले नहीं दिखेगा इन दोनों के बीच में.
ये जो लास्ट फेज होगा बेसिकली लास्ट में जब 2 ब्लॉक बचेंगे वो इस डिस्क पे नहीं आएगा, वो ऑन द फ्लाई हो जाएगा. तो रिड्यूस वन एक्स्ट्रा बेसिकली वन साइकिल बेसिकली.
और हाँ, दो का कोई रूल है क्या, या अगर मान ले 5 बच गया तो?
5 को कैसे करेगा ऑन द
क्योंकि
फ्लाई पे?
5
वो मर्ज सॉर्ट चलाएगा ना, यहाँ पे मर्ज सॉर्ट चलाता है मर्ज, वो तो दो के कॉम्बिनेशन पे चलती है शायद.
तो मतलब वो लास्ट एक साइकिल को कट करने के लिए उसका जो
कट करने के
फाइनल
लिए
होना चाहिए वो
फाइनल
2 ही
आउटपुट
बचता
वो,
है.
हाँ वो उसको डिस्क पे लिखने की बजाय वो वहीं से डायरेक्टली रिड्यूसर फंक्शन ऑन द फ्लाई कॉल कर देता है.
ओके, ठीक है. ठीक है, मुझे आई एम गुड.
ओके, एनीथिंग एल्स प्रभजीत? So this is what I explained up. So this is what I would explain on the slide only. Okay, so we looked at the different MapReduce things, how the MapReduce internally works up, and I wanted you people to run up some things so that you are able to understand this code also. So do you want to run at least a sample MapReduce, or do you want to try it later on and I explain you the advanced MapReduce word?
I think we can try it after the class.
ठीक है. So what I want you to do is just to try to put some file into HDFS. Try to run at least the word count one, this one only, the word count one, and to run it, this is the command which you have to run it. So you have to create this jar first, or if you are unsuccessful in creating the jar, you can practically get this jar from MapReduce one. This is a jar which you can download from here also. This is pre-packaged for you if you are not able to create this jar of your own by running Maven clean install से. उसके बाद में just try to run one MapReduce program with some putting some data into HDFS and look at the result. And once you're able to run it, then you will be able to understand most of the program जो मैंने यहाँ पे लिखे हुए हैं, input file format, reader, writable, all those things. So once you look at them, then if I explain them, then it will make more sense. otherwise अभी मैं बताऊंगा, you will just सुनोगे और भूल जाओगे, कुछ फायदा नहीं होगा. Okay, so then we can look at the advanced MapReduce things, and okay, so we can take a 5 minutes break and then we can look at the advanced MapReduce. Prabhjeet, is it fine if we, rather than at 11, we can just little bit extend to 11:30 or something. It's 10:30, right?
Yeah, it's fine. It's fine.
10:30 ना, हाँ ठीक है, 11:30 तक will wind up.
ठीक है मिराज 10 मिनट का ब्रेक ले लें क्या, मेरे को
ठीक है,
ब्रेकफास्ट भी करना है तो मैं
हाँ
10
हाँ
मिनट
ठीक है 10 मिनट
सो
का कर
लेट्स
लेना. So it's
लेट्स
10:40, 10:37 my watch. Let's meet at 10:50. ठीक है.
ऑलराइट थैंक्स.
ओके.
मिराज वन थिंग, अपना प्लीज फोन नंबर शेयर कर देना, वो क्लास का कई बार कंफ्यूजन होता है या कुछ पूछना होता है तो
अच्छा,
प्लीज.
फोन नंबर मैं एक सेकंड पिंग करता हूँ, यहाँ पे चैट विंडो पे पिंग कर रहा
ठीक है.
हूँ. ठीक है, मैं अभी जस्ट चैट विंडो पे पिंग कर रहा
ठीक है, चलो 10 मिनट में मिलते हैं फिर.
हूँ. ओके. Are we back?
Yes.
Okay. Shikhar? Shikhar there? Mm-hmm. Gone for the breakfast. You drive in Delhi or you live in Node only?
मुझसे पूछ रहे हो?
हाँ.
Yeah, I'm back,
मैं दिल्ली
Miraj.
में
Oh, okay.
आज
So,
दिल्ली है रिसोरी गार्डन.
अच्छा तो फिर ड्राइव करते हो?
हाँ मेरा ऑफिस 15-20 मिनट पे ही है डिस्ट्रिक्ट सेंटर.
So 1 तारीख से क्या करोगे?
1 तारीख से 2 गाड़ी है ऑडी 1.
अच्छा 2 गाड़ियाँ हैं.
बट वही है वो घर में किसी को चाहिए होगा तो प्रॉब्लम होगी तो देखते हैं,
अच्छा
करते
फिर
हैं.
सही. फिर सही है 2 हैं तो.
मैं तो ये सोच रहा हूँ यूएस मूव हो जाऊँ.
हाँ.
मैं कह रहा हूँ सोच रहा हूँ यूएस मूव हो जाऊँ ज्यादा इजी हो जाएगा.
हाँ सही है. यूएस मूव हो जाओ.
हडूप सिखा दो फिर हो जाता हूँ.
Shekhar will give you the job in his company.
हाँ मेरा H1 भी
Yeah,
है.
always I'm happy to help if I can.
मेरे पास H1 भी है. I have H1 भी.
So there is a special rule which is implemented over here, odd even in Delhi from 1st of December.
Yeah, I heard Kejriwal is like, I don't know what to say. I started his, I had a very good impression about him, but the way he messed up, he killed all hopes for anybody in future. People will not believe anybody else in future, even if they want to do something good.
This yeah, this happens. People just forget it. After 1 year, everyone will forget. That's all.
Yeah, that's true. Chalo, anyways.
लेकिन नहीं वैसे भी इंडिया में कोई कुछ नहीं करता है, सब पैसे खाते हैं. That's fine.
हाँ, लेकिन ये केजरीवाल का ना मुझे थोड़ा लग रहा था कि यार ये बंदा अपनी नौकरी छोड़ के वॉज एक्साइज कमिश्नर और इनकम टैक्स कमिश्नर.
थोड़ा
तो मुझे
एजुकेटेड
लगा कि यार
पता नहीं.
आईआईटी दिल्ली का था, तो मुझे लगा कि चलो ठीक है, बंदे में इतना इसको ये नहीं है कि यार अगर नेतागिरी नहीं करेंगे तो खाएंगे कहाँ से. ये मतलब दैट वाज नॉट हिज कंडीशन, राइट. जैसे देयर आर लीडर्स हु हैव लाइक, जैसे लालू अगर नेतागिरी नहीं करेगा तो ही कैन नॉट अर्न हिज लिविंग, राइट. तो मुझे लग रहा था कि केजरीवाल को ये सिक्योरिटी प्रॉब्लम तो नहीं होनी चाहिए, बट एनीवेज.
Okay. Okay. So So till while we are looking at how your MapReduce phase really runs up. There's a mapper phase, reducer phase. In between, there are a lot of other phases, a lot of other things comes in picture, and that's how your data is really processed in the cluster. So let's look at some other things which really help you to process your data faster, or if you have to basically some other handy tools which helps you in MapReduce thing. So we'll look into the partition in a minute. Let's look at the combiner first. So basically, if you can see on the mapper side, on the mapper side, on the mapper side, you can see I have two data with key 1 and two data with key 2. And let's say my objective is to get the sum of the values. So rather than passing 1 comma, basically I'll be passing this data as something like this: key as 1 and the value as 2, and then key as 1 and then the value is 2, and then key is 2 and then the value is 3, and then key is 2 and then the value is 3. So why not to call the reducer function itself on the mapper before sending the data to the final reducer? That will reduce my data transfer to the network. So combiner does the same thing. So what we'll do is, rather than sending 1, it will just send, so that the reduce function is nothing but the sum of the values. So 1 and 4, and then your 2 and 6. So this will reduce my data transfer to half on the network. So combiner basically calls a reduce function on the mapper. So you have to create your own combiner class which you have to define up, that will do the combination of the data on the mapper side, and that function will be called on your values on the mapper. So in 99.99% of scenarios of where your combiner will not be a separate class, that will be a same reducer class. So if you can see the code which I'm showing you to people is, I have implemented word count दिखा रहा था ना मैं, कहाँ गया word count. So you can see I've used the same reducer class, the combiner class, because if you are not doing thing like median or mean, if you are not doing those kind of thing, you can always you do the basically use the combiner as a class, and you can basically use a reducer class as a combiner class until unless you are doing things like median or mean. Okay, so let's look at partitioner. Partitioners helps you to divide your data or partition your data to the reducer. So let's say I don't want the default hash implementation to partition my data. I want to partition it by myself. So in those scenarios, I can use a partitioner. So let's look at one example and that will make it more clear. So let's say, okay, first I'll show you the data. Is my Hadoop running? अरे यार मुझे ये भी start करना पड़ेगा. Okay, just give me a second. Let me start it. Okay, by the time it's starting up, uh, you can see there are a lot of things which start up at the back end. So suppose me configured, so you don't have to worry about all those complexities, all this administration work. You have all pre-configured machine which you can directly use up. So that's just the reason we use. I normally prefer VirtualBox for the startup thing. So basically, this example is I have a data, something like this: name of the player, age of the player, his gender, male or female, and the score which he has scored in a baseball game. So this is the data which I have. My problem statement is I want to figure out max scorers in different age groups, so less than 20, 20 to 50, and greater than 50 for each gender. So who was the max scorer in less than 20 in male category and female category? Who are the max scorer in 20 to 50 category age group in male and female? And similarly, who was the max scorer in male group and female group in age above than 50? And my data has four fields: name, age, gender, score. So can you think of in the MapReduce word how can I solve it? Any thoughts?
So I thought you were running a program to
Yeah, I'm not.
show us that.
I'm still not running up. I'm just showing you the data, how the data it is. So I'm just opening the data file to show you the real data, which I want to.
Okay, ठीक है.
So this is my data: name, age, gender, score, name, age, gender, score, and so on. So now I have to write out a MapReduce code to figure out max scorers in each age group of the corresponding gender of male and female category.
Okay. तो पहले हमें कंबाइनर लेके मेल और फीमेल को अलग करना पड़ेगा.
कंबाइनर लेके मेल और फीमेल को अलग करना पड़ेगा.
Okay, then मेल के अंदर we will have to मैं सिर्फ जनरल लॉजिक से बोल रहा हूँ, ठीक है? तो then you have to divide it into three age groups, less than 20, 20 to 50, and
In
more
MapReduce you
than
can only
50.
talk in terms of keys and values only. What will be the key on the mapper side?
Okay.
What will be the key emitted out of the mapper? What is the key consumed by reducer? What is the key emitted out of the reducer?
Okay.
And basically
ठीक
when
है,
you're
फिर
writing a MapReduce code, you only write two functions, mapper function and reducer function. दोनों में एक key होती है, एक value होती है, जिसको आप implement करते हो, उसके अंदर कुछ logic लिखते
ठीक है.
मेल और मेल से ही की बना सकते हैं जेंडर.
हो. On the mapper. पहले तो सबसे पहले
मैप
बात करते हैं हम इनपुट फाइल फॉर्मेट कौन सा यूज करेंगे इसको रीड करने के लिए, या फिर हम अपना कस्टम लिखेंगे.
लाइन वाला आई गेस सेपरेटेड बाय
Default one.
लाइन.
The default one. Okay, we'll use the default one. That will give me whole this value all this thing as a value, and then I have to do something on the mapper class. So key जो आएगी वो हमारे किसी काम की नहीं होगी. We'll just ignore the key and this will become a value. Then
So basically हमारा स्लैश एन जो है वो each record break हो जाएगा.
each record break हो जाएगा.
And
for each record I'll call my mapper function.
और जो ऑफसेट वैल्यू होगा, सपोज हमने 00 से शुरू किया टॉप एलएस को,
तो वो हम तो इग्नोर कर देंगे, वो हमारे किसी काम का भी नहीं है. ठीक है, वो मैपर भी की आ गई, उसको हम इग्नोर कर देंगे.
एवरी 40 है.
हाँ,
तो पहले हमारे पास की आ जाएगा मैपर से ऑफसेट वैल्यू ऑफ बाइट, जो वैल्यू का नहीं है, बट एवरी लाइन विल बिकम अ वैल्यू टू अस.
यस,
करेक्ट.
यस.
Now what will happen is, now we have to read,
now somehow I have to do something
every line.
Yeah, now some I have to something I have to apply on the value. कुछ उससे की बनानी है, कुछ से वैल्यू बनानी है, और रिड्यूसर पे मुझे हर एज ग्रुप की वो निकालनी है. मेल की क्या होगी, मैक्स स्कोर. मेल का कौन मैक्स स्कोर है और फीमेल का कौन मैक्स स्कोर है फॉर ईच एज ग्रुप.
Right. तो हम उसकी वैल्यू पढ़ना शुरू करेंगे. So first would be the name. So it will be name. So then next would be, how do we know the first one is name? वो हमने वेरिएबल पे रखा है ना. Can you say the code? So you have name, age, gender and score as 4 variables, correct?
Basically this is tab separated data. On the value you have to tab separate it. So basically you have to split it on tab, and array के first thing जो होगी वो name होगी, second thing age होगी, third thing gender होगी, fourth thing score होगी.
Okay. So
but क्या की बनाओगे, क्या वैल्यू बनाओगे कि you can process it.
So then I'll make key as variable name जो हमने बताया है, name, age, gender और score. Those would be my key.
सारी की
and value would be all this.
Your data would, how will you?
बात तो सही है.
Think I'll give you 5 minutes. Myself on mute. Thank yourself for 5.
Can you just repeat that question again? Like हमें क्या क्या करना है?
हमारे को करना
यहाँ पे
कुछ,
कहीं खोल दो.
हमें कुछ करना कुछ नहीं है. हमें हमारा सिंपल सा प्रॉब्लम स्टेटमेंट ये है कि ये डेटा है मेरे को, इसमें से हर एज ग्रुप का जी लेस देन 20, 20 से 50 और 50 से बढ़ेगा, मेल का कौन सा मैक्सिमम स्कोर है और फीमेल का कौन सा मैक्सिमम स्कोर है, वो निकालना है.
Okay.
So, any clues?
No, I could not figure out.
Okay, so let's look at the partitioner. So although we can solve it with a map reduce also, but वो थोड़ा complex हो जाएगा. But let's look at how can we solve it with the help of partitioner. So what partitioner does is we can define how your data will be divided onto reducers. So what we did is we read the data with the default input file format. So हमारे पास keys आ गई, that is byte offset. हमारे किसी काम के नहीं थी values. Values were tab separated, which I split them on the tab, and we were able to figure out gender, name, age, and score. So हमने जेंडर को की बना लिया एंड नेम एज एंड स्कोर को वैल्यू बना लिया and we have written out of the mapper class. Now what we did, we created our own custom partitioner, accent partitioner, new class, new static class. What we did over here is we ensured that the data which has age less than 20 reaches one reducer, data greater than 20 and less than 50 reaches another reducer, and other than that data reaches the third reducer. So with the help of our own custom partitioner, we ensure that the data reaches the reducer जिस reducer पे हम चाहते हैं. So एक एज ग्रुप का डेटा एक ही reducer पे जाएगा, इसके अलावा किसी और reducer पे नहीं जा सकता. In the job configuration, we have set the number of reducers to 3. So reducer 3 ही बनेंगे, हमने confirm कर दिया. और उन तीनों reducer पे एक reducer पे मैंने
एक मिनट, कैन यू गो टू द फर्स्ट वन? पहले का तुमने क्या बनाया था? फर्स्ट जहाँ से ये कॉल किया
बनाया जेंडर,
वहाँ पे जेंडर का की बनाया
और वैल्यू बनाया,
और
बाकी सबको वैल्यू बना दिया, नेम एज और स्कोर को वैल्यू बना दिया मैंने. अपना एक कस्टम पार्टीशन बनाया. कस्टम पार्टीशन में मैंने क्या कहा कि मेरी हैश की मैंने उस हिसाब से बनाई कि लेस देन 20 के लिए एक अलग हैश किया है, ग्रेटर देन 20 लेस देन 50 के लिए डिफरेंट हैश किया है, और उस बाकी सब के लिए हैश किया लगा है. एंड मैंने नंबर ऑफ रिड्यूसर डिफाइन करके 3 ही होने चाहिए. तो यहाँ पे बेसिकली रिटर्न 0 कर दिया मैंने. यहाँ पे 1%3 1 रिमाइंडर ऑफ 3 बनाएगा, 2 रिमाइंडर ऑफ 3 बनाएगा. सो बेसिकली तीनों के लिए डिफरेंट हैश की बना दी, 3 डिफरेंट हैश की, सो दैट आई इंश्योर माय डेटा इज रीचिंग माय रिड्यूसर्स. मतलब ईच एज ग्रुप का डेटा एक रिड्यूसर के पास जा रहा है, इसके अलावा दूसरे रिड्यूसर के पास नहीं जाएगा. एंड रिड्यूसर के पास की क्या बन के जाएगी, फीमेल या मेल, फीमेल एंड मेल फॉर ईच एज ग्रुप ऑफ डिफरेंट रिड्यूसर्स. रिड्यूसर का सिंपल सा लॉजिक, जो भी मेरे पास की आ रही है उसके अंदर की वैल्यूज का मैक्स निकालना है और प्रिंट कर देना है. This become extremely simple. Got it? Let's try to run it. So let's try to run it. So
I don't know.
Okay, Miraj, give me a second. I think I need to enter the door.
Sure. So I'll just cost confirm the input file, as this is the only one which I was showing to you. User udp input, user udp input नहीं, user udp input udp output. Okay, I think output directory वहाँ पे exist होगी तो error मार देगा वो. So we can just see. Output directory already exists, so we have to delete it. So it's running now. So now you can see that it will create only 3 reducers. Data बहुत ही छोटा था, split एक ही है, make it a very small file for us in the sample data. So how many output files will be created?
Okay, I'm back.
So we are running the program, and you can see the 3 reducer will be created up, and yeah, it's done. So how many output files will be created? Each reducer will create its own output file because each reducer has its own Hadoop, record writer. Each record writer will create an own file. So you can see each file will have particular age group. So this file has age group of 0 to 20. Nancy was the female scorer highest. Adam was the male scorer highest. This file has your greater than 50 age group. 38 legend. Christine was the female and corresponding male. Data is sorted on female and male because those were the keys. And similarly in the third file. So we got the age groups, different age groups, and the corresponding genders of those age groups, the maximum scorers. Got it? What partitioner does basically?
Yeah, I'll have to try it, but I got the concept.
Okay. Combiner we just looked at. So mapper say partitions your data onto reducer. So this we have created our own custom partitioner. If we do not implement our custom partitioner, default partitioner comes in picture. So we overridden that and we created our own partitioner, and that's how we inference how your data would be sent to reducers. तो यहाँ पे जो data partition हुआ था, मैंने जो बताया था, but मैंने जो बताया था data partition हो रहा है हर reducer के लिए. So this is a partitioner which helps you to partition this data and later on this data and send to the corresponding reducer.
So basically, go back one more time. Yeah, so it is the one which is you're showing in the 3 blocks, which is data is written on the each partition. That is the step we have covered, and this is the step, right?
Yeah, so basically
which is on the partition, partition sort and
data. Yes. Partition this data. And these partitions then reach your corresponding reducer. This partition is intended for one reducer, for second reducer, third reducer. तो एज ग्रुप का डेटा इसमें आ गया, एक एज ग्रुप का डेटा इसमें आ गया, एक एज ग्रुप का डेटा इसमें आ गया, ये वाला रिड्यूसर एक एज ग्रुप पे है, ये वाला रिड्यूसर एक एज ग्रुप पे, ये वाला रिड्यूसर एक एज ग्रुप पे. हर रिड्यूसर अपने एज ग्रुप का डेटा मेल और फीमेल के लिए कीज बन गई. तो फीमेल जो हर रिड्यूसर का फंक्शन रिड्यूस फंक्शन 2 बार कॉल होगा, एक बार मेल के लिए, एक बार फीमेल के लिए. मैंने हर वैल्यूज में से मैक्सिमम निकाल मैक्स एज निकाली और प्रिंट कर दिया. Got it?
Yes, I'll have to try it, but got the concept.
Okay. Compression. So now you can compress the data into a SDFS. You can compress your data while emitting out of the reducer. You can even compress the data while emitting out of the mapper to your reducer. So at all the 3 phases you can apply compressions. There are different kind of a compression which are available over here: LZO, ZZip, ZZip, snappy. We'll look at all these compressions in the file format and compression class. Uh, then you can so how to set up this set up compression. All you have to do is just set parameters on your job configuring class, map.output compress to true and the compression codec which you want to use, and that will ensure that your map reduce output is compressed. Compression gives you a lot of benefit. We'll discuss the benefits in our class. The first benefit is you that drastically reduce your data sizes, and that if your data size is reduced, your IOs are reduced onto the from your disk. And if your IOs are reduced, and IOs are major bottleneck in any of the hardware which people are yet not able to solve up. So if your IOs are reduced, your data processing becomes much faster. So it's always recommended to compress your data, but which compression to use, that depends on the data and what you are doing up. But compression is always beneficial for you. There are disadvantages that you have to decompress the data, but you have to check your optimal path, how much CPU you require for decompress as compared to how much efficiency which you have achieved by compressing your data, and thereby reducing our IOs. So but compression you can apply at all the three levels, while from an input reading from your SGFS, output from the mapper, and emitting out of the reducer at all the three phases. Zero reducers, in some cases you might want zero reducer. That is all you want to do is you in the mapper only, like in a scoop. So when we look at the scoop, that will make sense. So a scoop, we don't require reducer. Everything is done with the mapper only. So in some particular scenarios, you might want reducer not to run up. So you can set the number of reducers, like we set the number of reducers to 3 in our previous program. You can set the number of reducers basically in your program. Okay, and distributed file cache. So let's say I'm running some Java code on the mapper phase or reducer phase where I want some jar file to be accessed, or some configuration file which I want to access while running my mapper code or reducer code. So in such a case, what you can do is you can just add your file to distributed cache by this way, and then you can easily access that file on all your nodes. So Hadoop will ensure that your file will be available on all the nodes which are running that corresponding mapper reducer for your thing, and that will be available locally. So distributed cache helps you in passing your some jars which you will be requiring everywhere, or some files which you will be requiring everywhere. You can just set them to distributed cache, and then you can refer them locally in your mapper and reducer code. So wherever mapper reducer code is running up, that jar will be first copied before running a mapper reducer instance, and that will be available locally in your mapper function, which will be running in your JVM on the corresponding node. Mm, any questions?
No.
Okay. So you first browse through this code. First browse through these all the different code components. I've explained you most of the things. Sequence file, map file, don't worry about that thing. But hive वाले छोड़ देना. But other than that, I've explained you most of the things. Just browse through them. Then I explain you in little bit more detail. Reducer side join, write table comparable. सब कुछ मैं आपको बता चुका हूँ. Input file formats, partitioner, problem और रहने देना. Weblog, web count, this I'll show it to you. Uh, so these things I'll show it to you, but अभी मैं सब कुछ दिखाऊंगा. आप लोगों ने कुछ चलाया नहीं है, तो you will get confused. So I don't want to show them to you right away. First, to try to run a few things, then only it will make sense to you. For me to explain to you. Here I have created custom classes to read it up and all those things. I wanted to show it to you, but first you people just try to run a few things. Then I'll show you these simple Java code which are there over here, and then we'll move on to Hive. So, but before next class, please try to set up your environment and try to run at least one MapReduce code. Then I'll show you running other codes also, and then we'll start Hive part. And I'll share you one problem statement also of MapReduce. So you will get in one PDF which have and also which have the detailed problem statement, and if required data will also be there. So just try to write that MapReduce code, and that will give you more understanding of the whole thing.
Okay.
Okay. So I'll share the problem statement with you on the same Google Drive. And इस कोड को भी
I
देखना.
just have a small request.
Yeah.
हाँ, ये last class में ना Miraj, the Excel file which you created.
यार वो Excel फाइल तो शायद मैंने
And
डिलीट कर दी.
this
Excel फाइल तो नहीं होगी शायद.
delete.
नहीं, वो तो क्लोज कर दी होगी मैंने.
Okay.
वो बट सेशन में आप
ठीक है,
रिकॉर्डेड
चलो.
होगा तो वहाँ पे दिख जाएगा आपको.
ठीक है, कोई नहीं. मतलब इतना भी वो नहीं था. Actually सेशन में क्या होता है ना, you have to play the whole thing to get to it, right?
या वो एक्चुअली मैं बस क्लास के बाद में बंद कर देता हूँ उसको.
कोई बात
वो
नहीं.
हर क्लास में आई जस्ट एक्सप्लेन ऑन एक्सेल एंड दोस थिंग्स. सो दैट इज वो तो देख लेता हूँ मैं. नहीं खुली भी नहीं है लैपटॉप पे, इसी पे दिखाई थी मैंने. हाँ, एप्पल ऑल पे दिखाई थी. नहीं है, इस पे नहीं है.
कोई बात नहीं. ठीक है, तो नेक्स्ट क्लास कब होगा?
सैटरडे सेम टाइम 8:30 IST.
ठीक है.
वीकडे में करनी है या सैटरडे करनी है? आई एम फाइन विद बोथ ऑफ देम.
वीकडेज में कर लो, कल परसों में.
It's 11 o'clock a.m. It's right. It should be bright now. It's
really?
dark o'clock.
So I am fine. Whatever is convenient to you people, I am fine with it. क्योंकि मैं I am free on the weekend also. I am free on the weekday also. Tomorrow I am free. I will not be free on, might be on 30th, but 31st तो वैसे भी कोई भी नहीं होगा. Tomorrow I am free. If you
कर
want it,
सकते हैं, I guess.
if you want it tomorrow, I can do it. Otherwise, we can do it on Sunday, Saturday also. Whatever your wish. Shekhar?
I am good either ways. Prabhajit, it's your call. You want to do tomorrow or I'm
ठीक है,
good
तो
either
कल.
way.
So I'll confirm you for tomorrow over the email. You will get an email somewhere around my morning. My morning 10 10-11 बजे तक. I'll drop you an email for tomorrow confirmation. ठीक है.
ठीक है.
Otherwise, if not tomorrow,
one more thing.
31st को तो हो नहीं पाएगी, क्योंकि 31st तो 31st नाइट होगी. Then we can have it on second or first night. देख लेंगे. ठीक है. You can just reply on the same email.
So why don't we set up a time and then go instead of putting it on a? We are all sure on second, which is Saturday.
Saturday will definitely have.
Why don't we do?
Saturday will definitely have. But before that, if you want to have class to wind up the things, we can have it tomorrow. Tomorrow I'll just confirm you over the email. Saturday we can definitely have.
So what I'm asking is, if we have a class tomorrow, then we don't have a class on Saturday. Is that what you're saying?
Or we still? I mean, we can have.
In either way, we have a class on Saturday.
If you don't want, we can discuss it tomorrow. मेरे को कोई, I am flexible with that. I am okay. मतलब I am flexible with that. I have to complete your course. वो चाहे आप 10 क्लास में करो, चाहे 5 क्लास में करो, चाहे एक दिन में बैठ के कर लो. Does not matter to me. I have to make you understand all the basics and the things which I have told to you.
Okay, so Prabhajit, would you have enough time between now to tomorrow to set up your environment and do everything?
My environment, like right now, VirtualBox is up and running. I was just asking some question about that. But maybe like if we can have a class where we can discuss
So what
like
I do is
creating the
normally after this theory, this is the major theory part, first three classes. After that, in
mm,
each class, what I do is half of the class is basically theory and half of the class is practical, where you people run up the things which I discuss up, and I try to solve the problem. So normally my class strength is 5 to 6 people. There's a class of only 2 people. So
mm,
problems थोड़ी सी questions थोड़े से कम आते हैं. So that could be little lesser practical, but definitely practical I have after each and every class. Half of the class I normally have practical to so that people run up the things.
okay.
So it's your wish, or what you can do is you can drop me an email, or I'll drop you an email. You can just reply it, and you want it yes or no, and then we can have it tomorrow. Otherwise, Saturday we should
Right,
have it.
right.
Okay?
Let's work it over the email tomorrow. Okay?
Okay. So okay, you can drop me an email, and if everyone says yes, so then we'll have it. Otherwise, we'll have it on Saturday. Fair enough.
Fine. एंड
Oh,
मिराज वन मोर थिंग
हाँ.
मैंने अभी रन किया है वर्चुअल बॉक्स तो वो रन हो गया है और मैंने अभी 127 o.o.1 उस पे मतलब किया रजिस्ट्रेशन भी किया है तो
Hmm.
रजिस्ट्रेशन भी हो गया राइट
Okay.
तो अभी मतलब वो वर्चुअल बॉक्स अप एंड रनिंग है
That's ठीक है.
तो
फिर you can try to run up now the program, MapReduce program, and I'll also share one problem statement with you. You can try to write that also.
ओके ठीक है
ठीक है.
ठीक
Okay. Okay then.
So,
Yeah.
for tomorrow's class, we'll have to watch your email at around 10:30 tomorrow, your time morning.
Sure.
Right?
Yeah,
Okay.
definitely. Before that only I'll drop you up. You can just say yes or no, you want it tomorrow or not, and then correspondingly we'll have it. I'll drop my yes or
Okay.
no.
Thanks.
Okay.
Thank you, sir.
Okay. Thank you. Have a nice day. Bye bye.
All right. Thanks, everyone. Bye.